Hello, this is Professor Salahat. In this short video, I'm going to show you a problem where we need to use um, StatCrunch to find or to test a claim about the mean when sigma is not known. And another thing is when data is given, because when we look in here at this is a list that you see in the problem here. This is a list that includes our data. So the first thing we do when we have a data like this one is we go and click on this link here next to the last number, which is 9.8, and we open StatCrunch. So the data will go into StatCrunch right now. It's loading. So here's our data into StatCrunch. Now let's read what the problem wants in here before we continue. In this problem here, let me summarize what we have. In this problem here, we have the following. We were told that the dean of a university estimates that the mean, so this is the mean problem. So in number 18, we're talking about mean. We're talking about mu. So the dean estimates that the number of classroom hours per week for full-time faculty is 11. So the dean estimates the same as the dean claims. So this is the claim. The claim is the mean is 11 hours. Because they said is in here, and is translates into equal. Now, so before I continue, let me stop here and write H note and HA. In this case, H note is going to be equal to mu, and this is also mu, and it is going to be equal 11, and I'm going to write here, this is the claim, and this will be the opposite, so it's going to be not equal 11. So this is what we are dealing with at this minute. Now, so we come back in here and we say this is the claim, which is C, which is equal, not equal. We check the answer. But let's proceed in here and see what they want. In this case, they tell us, as a member of the student council, you want to test this claim. I'm reading problem here. So as a member, you want to test the claim. So a random sample of the number of classroom hours of 8 full-time students. Notice that if you look at the data here, you're going to count them 1, 2, 3, 4, 5, 6, 7, 8. So there is 8 students, that's N. 8 students with alpha equal to 0.05. This is given in here. So you ran a survey and you only surveyed 8 students and you use alpha equal to 0.05. Can you reject the dean's claim? So let's continue in here. We need to find the p-value, and from there we need to see if the p-value, and we compare it to alpha. We compare the p-value to alpha to decide if we're going to reject H naught or fail to reject H naught. So how we get the p-value using StatCrunch? Here are the steps. Now, notice that in the problem, we read the problem, sigma was never, ever mentioned. And again, sigma is the population standard deviation. Sigma is unknown because, again, when you read through the problem, there is no mention of population standard deviation anywhere. So we follow those steps. We go, we fill the data. Again, the first thing is we do is we put our data into StatCrunch, and we put it under variable 1, which we did. So here's our StatCrunch that we worked with. Let me pull this down. So we pulled our data into StatCrunch. Then after that, you go to Stat, and you're going to go to tstat and you go to one sample. But be careful in here, since data is given, we don't go to summary, we go to data. I'm clicking on data here, and now we see variable 1. Since the data was under variable 1, notice that we put the data under variable 1. So we're going to click on variable 1, and it's going to go there. Now we come down to the test, and we're going to make the test match what we have in here. So this is our test here. This is our hypothesis. So H naught will be equal to 11, and the HA is not equal to 11, and compute. So the p-value in our problem is listed at the end of the list in there, which is 0.05. 0.1808. Notice that the alpha is 0.05. It is here. So since the p-value bigger than alpha, as you can tell, 0.18 is bigger than 0.05. So in this case, we're going to fail to reject H note. So we're going to go up here and we're going to go here and write next to H note fail to reject. And what we're going to do to HA is reject. So let me expand this and see what is happening in here. Notice that we are failing to reject the claim because H note happened to be the claim. So let's go back in here and try to fill this in. First of all, they asked me what is the p-value. So the p-value is 0.18, and again, the 1 3 places is going to be 181. The next step will be decide to reject or not to reject. So let me put this away. Notice in here that we failed to reject H note. So it's going to be either A or C. One of the two is either A or C because B is rejecting and D is rejecting. So let's see which correct. Is it A or C? Now in A it says fail to reject H note because the p-value is greater than the significance level, which is true. The p-value is greater. Notice that C says fail to reject H note because the p-value is less, which is not correct. So our correct answer is the A. So when we check the A, we get the correct answer. The last thing in here is, what about the claim itself? What should we do to the original claim? Should we accept it or reject it? Notice that the claim is H note, which is not rejected. So at the 5% level of significance, there is not sufficient evidence to reject the claim, A says, and we'll continue the rest of A later. In C, it says at the 5% level of significance, there is not enough or sufficient evidence to reject the claim. So it's going to be either A or C, because if you look at B, it says there is sufficient evidence to reject the claim. And in D, it says there is sufficient evidence to reject the claim. Notice that we said in here, there is not enough evidence to reject the claim because we are not rejecting. So we're going to choose between A and C. So let's continue. You notice A and C are identical until we get to the final statement that the mean, here it says the mean number of class hours per week for full-time faculty is less than. That is what it says. The claim is saying that. The claim is saying it's less. Now in C, it says the claim is saying it is the claim that mean number of class hours per week for full-time faculty is. Notice going back to our problem, here the claim is saying is. So it is a match of C. So C is our correct answer. And that is the correct answer for this problem. Now, for the number 19, we are moving now into proportions. So number 19, we are moving into section 7.4, which is proportions. And there is a condition in proportions, and the condition is that to avoid bias in statistics, we want both the n times p and n times q. What is n times p? N is the total number in the survey. And the p is the proportion of people who say yes. And the q is the proportion of people who say no. So n times p will be the number of people who say yes, number of yes, and nq is the number of no. Now we want the number of this is the number of no's to be at least 5. At least 5 to avoid bias. Because here is the case. Let's say that you went and did a survey and you surveyed 100 people and 2 people said yes and 98 said no. Then we assume automatically there is a bias. Let's say that you went and surveyed people about abortion and 98% are against proportion and 2 are for proportion. Now we we assume automatically that maybe you went to a place where, let's say, a church, and you did the survey, and therefore there is a bias there. So the breakage in here is that this NP and NQ must be, again, we have to have normal distribution, a condition for everything we do, but also NP must be greater than or equal to 5 and NQ is greater than or equal to 5. That is the condition, okay? Not bigger than 0, not less than 5, not equal to 5. The condition is we need to have the number of yeses at least 5 and the number of no's at least 5. When we say at least 5 means greater than or equal to 5, greater than or equal to 5. So that is the condition. Now, I'm going to stop here and I'm going to continue in another video for a proportion.